you turn sideways.
Yeah.
Okay.
Duty
It's our
calls,
calling. Yeah.
Mr. Ely, you gotta let us fly.
All right. Today we're talking about position. Yeah, they are. Today we're talking about position, velocity, and acceleration. Okay. This is not something that's extremely complicated, but you just got to be sure you understand it, and be sure that you understand the words and all as they come through, because you can get very tripped up sometime with the words. If you don't think about things carefully, you can make mistakes as well, okay? So, you've been finding average velocity for a long time. Average velocity is distance divided by time. So, if Grant leaves school here now, and Grant drives home, which is how far?
Oglethorpe's going 35 minutes.
All right, distance.
Distance, 25 miles.
All right, if he drives 25 miles in half an hour, you can figure out what his average speed was. 25 divided by a half hour, he averaged 50 miles an hour. Okay? You've been doing that since probably 7th or 8th grade somewhere. But that's an average speed. Does that mean that he was driving 50 miles an hour the entire trip? No, because his car wasn't moving when he got in it. And somewhere down the road he had a red light to go through. And somewhere down the road he was speeding. So at different places he was going at different speeds. But the average velocity would be the 50 miles an hour that we found out. Okay? So we're going to just kind of review that right quick. The average velocity. Now, average just means just what we said. It's the average over a length of time. So I want you to take this equation right here. That's the speed of a book being dropped. Excuse me, that's the position of the book being dropped. S stands for position. No, I don't know why we use S, but that's just common to use S. S is the position. I want you to find the average velocity. First of all, how will we find it from 1 to 2? What does that mean?
1 second.
1 second and 2 seconds. So we're going to find out, we want to find out what is the position at 2 seconds minus the position at 1 second divided by 2 minus 1. Why can't we just use 9.8? That's
Gravity.
it's a book. We're in feet. We're not in meters per second. And we're trying to find the average velocity here, okay? We may be getting to what you're just trying to get to there, okay? But we're just going there a little bit. We're not there just yet. So find the average velocity, class, in the next 30 seconds for that particular problem there. That is S. S at 2. Our function up here, our position function, is denoted by the letter S. So S of 2 minus S of 1. How do I find S of 2? Plug in and chug out, okay? So find from 1 to 2, find the average velocity. Average velocity. And the function again is negative 16t squared plus 160. Because to find the average, you take the position, how far we've gone, divided by the time that we've taken to get there. See, S of 2, when we put 2 in here, we get 64, we get 96. That means after 2 seconds, this book has fallen to where it's only 96 feet above the ground. Okay? When we put 1 in there, we get 16, we get 144. That means this book starts at 160 feet. After 1 second, it's at 144. After 2 seconds, it's down at 96 because it keeps on falling down. Now, the distance that is traveled from 1 second to 2 seconds is the difference between those two. So if I subtract those two, I get 48, negative 48, over 2 minus 1, which is 1. So the average velocity of this book is not meters. From 1 second to 2 seconds is negative 48 feet per second. That's the average velocity from 1 second to 2 seconds. Why is it negative? Because it's falling down. Very good. Now, do you expect to get the same number, the same answer, negative 48, when you do 1 to 1.5? So let's try it and see what happens, okay? Do 1 to 1.5.
You just plug in the negative 16t plus 160, right? For the S's.
Yes, negative 16t squared.
Now where the t's go? Rather than
I plugged in 1.5 4t.
Wait, so you plug in the final. Oh.
Hey, I'm plugging, this is my t value. That's the time at 1.5 seconds. So I'm putting t into there and squaring it and getting 2 1/4 times 16, the negative 36, and adding 160 and getting a number. I think that, oh, that's right, 124. Did anybody else get the 124 out of that?
I got
One.
negative 40.
Okay. And that is 1.5 minus 1. Really? Oh, this is not 96 back here, is it? 1 is 144. Oh, that works better. So that's 20 divided by, negative 20 divided by 0.5, so it's negative 40 feet per second. Okay, the 124, this is the position at 1.5 seconds. So I put 1.5 into this equation up here for t, and because that's my, think of that as my x number. This is the time, 1.5. Doesn't matter. I could have done s of 1 minus s of 1.5. It doesn't matter as long as I'm consistent with it. Yeah, but then the bottom would be negative, so you'd still wind up with a negative number. Yes, ma'am? Did you get it? So, from 1 to 1.5, is it going faster from 1 to 2 seconds or 1 to 1.5? 1 to 2, okay? What do you expect now to get for the answer for this here, 1 to 1.1? Do you expect a number smaller than negative 40 or larger than negative 40? Smaller. Why?
Because it went down when you went down. Let's say 25.
What's going to happen to this book the longer it's falling? It's going to get faster all the time. Why is it getting faster all the time? Gravity keeps pulling down on it.
What about terminal velocity?
Okay, we're not going to get there in 160 feet. If we had terminal velocity, then we'd eventually have to worry about that. So we would expect that if we did this here to get a number smaller than 40, and I think if you'll go through and do it, I think you might get negative 32 feet per second. I don't know, but something like that. But here's what I want you to understand. Have we done any calculus here? This is average velocity. Well, now, what is instantaneous velocity? At that split second, okay? When the police give you a speeding ticket for going 65 and a 55, is he looking at your average velocity or your instantaneous velocity? Instant, because he hit you with the radar, and in that instant he knew you were going 65. He didn't have somebody sitting a mile up the road and say, all right, what time did he pass here? Click, and click it again a mile down the road. He got an instantaneous velocity. You were doing 65 miles an hour. How do we figure instant, and I'm not looking at you just because I think you've been speeding, okay? You just happen to be the person in my line of sight here. How do we find instantaneous velocity? Okay? Instantaneous velocity, where's instantaneous? Oh, I haven't talked about instantaneous velocity yet. I did? Oh, instantaneous velocity is where we get a derivative from. We get a limit. We get a derivative.
The limit process.
The instantaneous velocity, is the derivative of the position.
What is the negative 16? Is that just like a formula for double?
Yes, that's the formula, and we'll talk about how we got that in just a second, okay? This is just the formula for this entire problem right here. So, To find instantaneous velocity, you couldn't do before this year, okay? Instantaneous velocity requires the derivative. Now, you could go through and do the limit process if you wanted to, but if this is our position function, we just said that the velocity is the derivative of that. How could I find the derivative of negative 16t squared, please?
Derive it.
Negative 32t. So suddenly we have a formula for finding the instantaneous velocity at any given time. So if I want to know how fast is this book going at 1 second, what do?
Maybe negative.
Negative 32. What about at 2 seconds?
Negative 64.
Negative 64. I just plug in the number. But I want you to understand that's the instant that it's at 1 second. When it gets to 1.01 seconds, is it going faster or slower? Faster. Every incremental part of a second, it's getting faster all the time. Big ticket to walk away out of this slide with. The derivative of position gives you acceleration. Always. Okay, so if I give you position of anything, you can get the velocity by taking the derivative. We'll get there in a second.
So we don't need to use the limit process.
No, you can if you'd like to, but you don't have to, okay? You don't have to.
Still don't know how to do it.
Now, this formula, if you are in physics or in physical science, should look familiar to you. Does it? Not yet? Okay.
It did, yeah.
All right.
Physical. I mean, for physics, but not
Yeah.
One
All right.
half AT squared.
1/2 AT squared. All right, now, here's what I want you to understand. This is something to commit to memory right now, okay? The position of a free falling object with no wind resistance. What does that mean?
No wind is pushing it.
No wind's pushing it anywhere, and it's falling down, okay? We're not talking about how fast Connor can run up and down the football field tonight.
infinite speed.
We're talking about something that's been dropped from a height or something that's been thrown directly down from a height. We're not talking about something that we throw this way. We're talking about something that's going straight up and down is all we're talking about. This will always give you the position of that. Okay? V sub 0, you'll hear me call V naught. V naught is the initial velocity.
Oh, yeah, then we have one.
All right?
It just doesn't-
Y'all probably just, y'all just VI, okay? S sub 0, you'll hear me call S naught, not snot, S naught is the initial position. Okay? XI, yes.
Oh, yeah.
So this is going to be a little bit confusing, you physics people, because where you're using X's, I will be using S's, and where I'm using V sub 0 and S sub 0, you're using V sub I and X sub I and stuff like that. But it's all works out to be the same thing, okay? Okay. This is V sub 0 times T. T is a time.
So it's like VI. Yeah.
VI times T, does that ring a bell?
Nope.
Yeah.
Initial.
Initial velocity times time. The same thing with this first part. It stands for 1/2 times G times T squared. What does G stand for? Gravity. How fast something, wherever you're at, how far quickly is it pulling you to that surface, okay? If we're on Earth, here's the numbers that we use for gravity. If we're in feet, you use negative 32 feet per second squared. If we're in meters, we'd use negative 9.8 meters per second squared. Okay? So this is just a matter of plugging stuff in and getting answers out, okay? If this is my position function, what is my velocity function?
Wait, that's seconds, right? That's not seconds, right?
No, that's seconds. That's seconds.
You're right, feet per second is like X.
It's a derivative.
Right. Our velocity is the derivative of position. So how do I find the derivative of 1/2 gt squared. What's my variable in 1/2 gt squared? T. G is a constant number. So if I take the derivative of 1/2 gt squared, what do I get? 2 gt. I get 1/2 times 2 times g times t. That's going to make it just gt. What's the derivative of v naught t? What's the derivative of this term? V sub 0 t. V sub 0. So my velocity function is always gt plus v sub 0.
Is that a plus?
That's a plus. T's have a tail on them for me. And pluses should not. So you can commit this to memory. You can commit your position function to memory. You can commit your velocity function to memory. Or you can just say, I can take the derivative of position to get velocity. All right? Yes, I can.
Jacob needs you to wait. He's the only one left. I'm not doing it. I'm not holding the class back. And the bottom one is the velocity.
This is velocity, okay? It's important that you understand I'm saying velocity. I didn't say speed, did I? What's the difference between velocity and speed? Velocity has direction. If the velocity is negative 32, what's the speed? Just 32. Speed is just 32. Velocity is negative 32. Velocity says I'm going in whatever the negative direction is at 32 feet per second.
And our vector has direction and magnitude.
We have position. We have velocity. Acceleration. What do you think acceleration is? Calculus related. What is acceleration?
It's like changing distance every time.
Exactly. Acceleration is the derivative of velocity, or the second derivative of position.
So could you do that in like a physics class?
Yes, sir.
Oh yeah, I think Mr. Hawkins done that.
So acceleration, look, my velocity is gt plus v sub 0. So my acceleration is simply g.
I'm learning more.
What's the g stand for? T is time. So we're going to be measuring time in seconds. So how many seconds something's going on, okay? Now, big ticket to take away with all of this. If I can find a highlighter. I don't even know where highlighters are on this. There. Highlighter, thank you. Big things to take away from here. That, and this. Okay, listen to me. These problems, there's one of these problems on your next test. There's one of these problems in the FRQs that are due next Friday. These are always going to be word problems that you've got to read through and think. There is no hard calculus in any of these problems. We've done all the calculus. You commit these three things to memory and you've done all the calculus. The rest of it now is thinking through things. That's why I love this so much. We're thinking through things. So, commit these to memory, or begin committing these to memory. Let's play with a problem. At time t equals 0, a diver jumps from a platform diving board that is 32 feet above the water at a velocity of 16 feet per second. That's a very good question. We need to think about what's going on here. Now, this is the type problem that you're going to be given. It's not going to be specified which way is he going. It's not going to be specified this is this, this is that. You've got to think about real life. What does it look like? So what does it look like? We have a platform diving board here. And we have some water down here. Okay? Okay? We have Jacob. Okay? Forgive my artistic ability here, okay? If Jacob is jumping from a platform diving board, what is he doing? Okay?
He has a really strong leg, so he might just keep going.
He's going to go up and come down like this, okay? So he's going to go up, and then he's going to come down. That's what we,
He could
It's-
do belly flop though.
but it's not explicitly says, but it says he goes up. If I say somebody jumps, what do you think?
He does that.
Jump. So that's what we're thinking. He goes up, and then he comes back down. Okay? Now, what is the position function for him here, okay? Remember, our generic position function is negative 1/2 gt squared plus v naught t plus s naught. When I say write the position function, all I want is t's and numbers over there.
What is the
Is that negative 1/2?
S is position. S sub 0 is initial position. Where is he at initially?
32 feet?
He's at 32. Now, here's something that's oh so easy to me, and I hope I can get it across to y'all. How do you measure the position of something? Yeah, position, what units do you look for when you measure position? Meters or feet or something like that. You don't measure position in time. So if you have no idea, look up here. Where is something that's measuring distance? Feet, so it has to go there. There's no question about where it goes. You don't have to understand any physics or anything there to know that's got to be 32. All right? What's going to be our initial velocity? 0. Okay? Why do you say 0?
He's starting at
Okay? Now, common thought is he's not moving there. If he's not moving, then he's never going to move. He's going to stand here. We don't have a problem today.
But they get on the
Okay? So understand, if I stand here and I'm not moving, and nothing ever happens.
But initially he did it.
Okay? Initial means when we're talking about, initial means right here. The first thing he does is he's got to jump, because if he doesn't, if he just stands there, we don't have a problem to solve. He's just going to stand there forever and eventually get disqualified because he took too much time. So you've got to do something. So his initial velocity is 16. Is it positive 16 or negative 16? Why positive? He's jumping up. Okay? What if this were a murder mystery and Ross took Jacob and threw him down off of a building at 16 feet per second? Then it would be negative because he threw him down. Okay? Would that make a difference in how fast he's going to get to the ground?
Yes.
Why?
because I'm strong.
Because he started off with a push going down, okay? So, we've got this much. We've got 32 S sub 0, 16t. What are we going to put for G?
9.8. Negative 9.
Why negative 9.8?
He's going down.
Because he's going down. No.
Oh, no, it would be positive on way because that's the way it's
But since we're using feet, we would have to put the
Negative
negative.
32.
32. Very good. It's going to be 32 since we're in feet. So we've got negative, that negative not supposed to be there, is it? We've got 1/2 of 32, which is what? So we've got 16t squared plus 16t plus 32.
How are we going to do half of 32?
Because the formula says 1/2 g t squared. G is gravity. We're measuring things in feet, so he's being pulled down at, the gravity is 32 feet, negative 32 feet. 1/2 of negative 32 is 16. Negative 16, I mean.
I know half of 32 is 16, but I don't know why we use 32.
Okay,
The formula.
you understand that G is gravity, right?
Sure.
Okay, let's back up. G is what we're using for gravity. Means what's pulling him down to the earth. Gravity is accepted as negative 32 feet per second squared on Earth. So we're going back to this statement right here, that you've just got to know. G is negative 32 feet per second squared.
So we're not using the 32 feet above and beyond.
Correct. Very, very good point there. We're not using this 32 for that G. We're using the 32 that's in our head.
Are we always going to do it feet or
It depends on what it's measured in. It could be meters.
So negative 16.
Negative 16t squared. 9.8. Very good. All right, now, So we've done a part. When does the diver hit the water? When? So what are we asked to find?
We want to know where the
Time.
How high the water, how high the diving board is.
We want to know what T is. We're looking for T.
Can we do this off the line?
No.
When,
Or the extra?
okay, so my question is, what are we going to do? Why? Whatever you say, my question is why. Yes, sir.
If you hit the position equals something,
All right, what do you want to set it? I can set it equal to anything you want to. Why 0?
because of the when he hits the water.
When he hits the water, what is his position? 0. Remember, this distance right here is measured from the water. So we're going to take his position, negative 16t squared plus 16t plus 32, set it equal to 0. Solve the problem. How many answers do you expect to get? Did he hit the water twice? Why is one negative? What does that mean?
He skipped it before.
No.
There can only be one Highlander.
It's like if you were to come back.
Anyone see that?
Because it's a parabola.
If
You
it,
understand it?
do y'all see a do y'all see a part of a parabola there?
I see a parabola.
If we completed that parabola back over here, then we'd have the negative one, okay? So, y'all are doing some math there, right? What's the first thing you're going to do there?
Solve it.
Factor out a 16.
Let's see if we can factor out a negative 16.
You can do that?
Yes, sir.
Man.
The negative 2 and positive 1.
So suddenly this became a lot easier. We can factor out t minus 2, t plus 1.
Can we double factor?
T is 2, t is negative 1, right?
What happens to the 16?
All right, what is this saying here? Negative 16 times something is 0.
It's irrelevant.
Is negative 16 0?
No.
So we can throw him away.
Yeah. That's it.
So what's our answer then? 2 or negative 1? 2. So that means 2 seconds after he jumped off the board, he hit the water.
Why wouldn't it be negative 1?
Why wouldn't it be?
Can't go back in time.
Remember, t is time. Time is negative 1.
Where did the 16
All right, right. This is 16 times something is 0. Well, we know it can't be 16. It's got to be the something. So, okay. So we got t equals 2. C part. What is the What is the diver's velocity at impact? How do we figure that out? Okay. V sub 2. V sub t is what? We said gt plus v naught, which here is what? Negative 32t plus 16, right? We took the derivative of this thing up here. I took the derivative of position. So it'll be minus 32t plus 16. And we're going to just put in 2, right? So velocity at 2 is negative 64 plus 16. Why would it be negative? All right, let's go back. Velocity is derivative of position, right? Our position function was negative 16t squared. So when we take the derivative, it has to be negative 32t. Okay? Position is negative 16t squared plus something. So when we take the derivative of that, it's 2 times negative 16, which makes it negative 32t.
So you didn't just put in negative 32 for G because that's what gravity is?
That's what I was thinking.
Yes, you could put in negative 32 for g because that's what gravity is. Yes, either way.
And then why is the G in the 0?
Remember, v sub 0 is initial velocity. What was his initial velocity? 16. His initial velocity was 16, so that's how we got that. And we plug in 2. So he's going negative 48 when he hits the water. Yes, ma'am.
So in this class, like when you go down, it's a negative.
Yes.
Okay.
Down is considered a negative direction here, okay? Now, I really want you to get a good understanding on this because it's very easy to get some of this stuff confused because some people don't teach it right. I've seen people that have taught AP Calculus for 30 years that don't teach it right, and I've explained to them how they've taught it wrong. So please, I want you to be sure you get a good understanding. The signs are really critical here. Always, and probably here in a couple of weeks, somebody's going to want to say, isn't the velocity zero when he hits the water? What if it were the ground? Okay, now understand what y'all just told me. Y'all told me that if he's on water, this formula holds, but if he's on ground, it doesn't?
If he's going fast enough,
Well,
water
they
is
measure
just like concrete.
It's
like
the
running.
instant he
Right.
touches it.
Bingo.
Instant he touches it.
Yes, this is the exact second he touches the water or the ground or whatever, he's going negative 48, okay? If it's the ground at 2.01 seconds, yeah, he's going zero, okay? If it's the water, he's going noticeably slower after that. But at the exact instant he hits, because if he's going zero, what does that mean?
We don't have a problem.
We don't have a problem, he's not moving, okay? If I'm moving zero, I'm not moving, so I can't be hitting anything.
There was a Mythbusters episode where they did all this stuff, the same equations, but when they dropped some kind of like a mannequin from a helicopter.
Mhm.
and tested all that stuff.
Yep, and they probably had to factor in gravity, wind somehow or another there, because it could have an effect on it, okay? Does this seem easy to you?
Yes.
Good, that's what it's supposed to be, okay? Now, you have 4 problems. You're more than welcome to play with them now. You're more than welcome to play with them over the weekend. You're more than welcome to play with them on Monday, whatever you want. The next time I will be teaching anything in here is Tuesday morning, bright and early. We will be introducing the derivatives of ease, which is very easy. That's the last topic before the next test. You have a WebAssign Monday due, a WebAssign Tuesday due, 3 FRQs due next Friday, and you'll have at least a quiz next week sometime too. So test probably the week after next is what we're looking at now. Okay?
Hey, for 97.
Outside next period?
I don't know. We'll see.
Please,
We'll see.
Are we gonna start our? Yeah, I feel like y'all ready outside.
Oh, I tried.